Dear students, now we can discuss an important topic in organic chemistry, that is nothing but arrow formalism. You may know what are arrows, so we are discussing arrow notation or arrow formalism. Generally, arrows are used to represent either the transfer of electron or to represent a reaction. That means we have two types of arrows called electron arrows and reaction arrows. Electron arrows simply represent the transfer of electrons like AB. So we are representing the transfer of electrons. And reaction arrows, A plus B gives C. So it represents a reaction. So generally, arrows are used for representing the transfer of electrons or for representing reactions. Now we can think about two types of arrows that we are usually used in organic chemistry. First arrow is called curved arrow. Curved arrow. The second one is called half hook arrow or fish hook arrow. Fish hook arrow or half hook arrow. So these are the two types of arrows that we are commonly used in organic chemistry. So first one, curved arrow. You know what are curved arrows. So in this way we are representing curved arrow. So in every curved arrows there will be a tail as well as a head. Is it? So tail as well as a head will be there, and the head represent the transfer. Is it? From tail to head there is transfer of electron, and that is curved arrow. And we can have this curved arrow either for representing cleavage, like if we have a bond like this, consider a molecule A2. Okay, consider a molecule A2, and in this A2 molecule, we can first consider the molecule AB. Okay, AB. Okay, consider the molecule AB, and this is diatomic molecule. If I am representing this arrow, okay, a curved arrow. What is the meaning? Curved arrow meaning is that these two electrons located to B. That means as a result of this you will have A plus and B minus. Is it? So this same we will discuss under heterolytic cleavage, but now curved arrow represents transfer of two electrons. Or another example, if you are having a reaction OH minus plus CH3Br, this is a reaction we will discuss under SN1 reaction, and if I am representing like this curved arrow okay, and like this, what's the meaning? This OH minus attached to, or these two electrons attached to CH3, and you will get CH3OH plus Br minus. Okay, so in this way curved arrows, and curved arrows are otherwise called double head arrows, okay, or tail head arrows. And curved arrow was first introduced in 1922 by scientist Robert Robinson. Okay, and now we are commonly used curved arrows for representing reaction as well as for representing the transfer of electron pair. Okay, transfer of electron pair is by curved arrow. Okay, the next is fish hook arrow or half hook arrow. What are fish hook or half hook arrows? You may know these type representations are there for half hook or fish hook arrow. Okay, in these arrows, actually if we are having a molecule A2, okay, and A2, if I am representing this curved half hook arrow or fish hook arrow, what's the meaning? It represents transfer of only one electron. Only one electron gets transferred, or in this case equal sharing, and you will get A dot plus A dot, and we will discuss this under homolytic cleavage. Okay, and half hook arrow or fish hook arrow usually used for representing what? Homolytic cleavage. Homolytic cleavage. Okay, so homolytic cleavage or movement of single electron. So these are two types of arrows. Curved arrow means two electrons or electron pair is transferred. Electron pair, two electrons gets transferred. So from A to B, if two electrons are transferred, A become A plus and B becomes B minus. Half hook or fish hook arrow means equal sharing or transfer of single electron. As a result, free radicals are generated. Okay, so the same we can discuss under bond fission also. Okay, now we can think about bond fission. There are two types of bond fission. Which are the two types of bond fission? Homolytic bond fission as well as heterolytic bond fission. So two types of bond fissions are homolytic as well as heterolytic. Okay, so first of all, what is meant by homolytic bond fission? Homolytic means equal cleavage. So bond fission, first of all we can think about bond fission, is it? Bond fission means breaking of a bond. So you can have different types of, okay, so we are simply thinking about covalent bonds, and if you are having a covalent bond like this, okay, so this bond is cleaved. The breaking of bond, that we will discuss under bond fission, breaking of bond. Okay, how a covalent bond can be broken, how a covalent bond is breaking. Okay, so for that, first of all, homolytic fission or homolysis. Homolysis or homolytic fission means each atom occurs one electron. Each atom occurs, gets one electron. Okay, each atom gets one electron, and that is already we have discussed under what? This half hook arrow. So half hook arrows or fish hook arrows are commonly used to represent homolytic cleavage, and in this case like this AA, if homolytic cleavage occurs, what are the products? A dot plus A dot. So free radicals are generated. So the important point is, what are the products of homolytic cleavage? Free radicals. Free radicals are the products of homolytic cleavage. Okay, free radicals are the product of homolytic cleavage. And what is meant by homolytic cleavage? Homolytic cleavage means each of the atom occurs one of the bonding electron. The bond is cleaved, partial cleavage or equal sharing of electrons. Okay, and each atom gets one electron. And homolysis or homolytic reactions are initiated by, or homolysis, it is also called homolysis. Homolysis is initiated by, when this homolytic reaction or free radical formation take place, homolysis is initiated by heat, light or presence of peroxides. Heat, light or in presence of some peroxides. So these are the ways to introduce homolytic cleavage. So as a result of homolytic cleavage, free radicals are generated and they are electrically neutral, and each atom gets one electron. Okay, and that is what is called homolytic cleavage or homolysis. Next we can think about heterolytic fission or heterolysis. Okay, so what is by heterolysis or heterolytic fission? Yeah, each atom occurs both the bonding electrons. In heterolytic cleavage, each one of the atoms in a bond, generally two atoms, so one of the atom gets both the electrons, gets both the bonding electrons. Okay, one of the atom gets both the bonding electrons, so that is called heterolytic cleavage. For example, if AB, is it, and if I am using curved arrow here, curved arrows, transfer of two electrons, is it, both the electrons, so you will get A in the poi, so A plus plus B minus. Okay, and if we are having like this with carbon atoms, we can have, there will be formation of cations and anions. If they are carbons, we can call the carbocations and carbanions. So carbocations and carbanions are the products of what? Heterolysis. So you may be asked, what are the products of heterolytic cleavage? What are the products? Carbocations and carbanions are the products of heterolytic cleavage or heterolysis. Each of the one atom gets two electron. Okay, and if A is more electronegative than B, you can have this representation. Then it will be like A minus plus B plus. Okay, which is more electronegative, towards that atom both the electrons will migrate. Okay, and anions and cations. Similarly, cations and anions will be obtained. Okay, so that is what is called homolytic and heterolytic cleavage. Okay, then we can think about polarity of bonds. Polarity of bonds. So what is the polarity of bonds? You know that a covalent bond, is it? A covalent bond is formed. If it is formed from A and B, you can represent this as AB. Okay, and if two atoms are same, like AA, what? These two electrons will remain intact. There is no migration of electrons towards A or A because both are A's. Is it? Random A anengil, there is no unequal sharing. Both the electrons are in that bond itself. There is no shift of electrons towards one A or second A because both are A's. Okay, that means if two atoms, two similar atoms or say similar atoms or atoms with a similar electron negativity. So we will, you know what is the electron negativity and what are the factors affecting electron negativity, that all we have discussed in first sum. So if two atoms having similar electron negativity, there is no shift. There is no shift of electrons because both are same. Okay, if two persons are there with the same strength, two are equally strong, there will not be no change, is it? But if one is equally one is more stronger than the other one, there will be change, is it? Like that. If two atoms with a similar electron negativity, the covalent bond will be there. But if we have atoms like AB and consider that B is more electronegative, and consider that B is more electronegative, you know which are the electronegative atoms, and is it? And when B is more electronegative means more electronegative. When B is more electronegative, B will withdraw electrons towards itself. So there is a shift. Actually, even though we are using this curved arrow in representing polarity, we are not using bond breaking. This is not bond breaking, so it's better to represent not curved arrow. Curved arrow പറയുമ്പോൾ നമ്മൾ bond fission വിചാരിക്കും അല്ലേ? So it is better to represent this. That means in inductive effect, we will discuss this under inductive effect. In a bond, if I am having an arrow like this, what is the meaning? B is more electronegative than A, and there is a slight shift of electrons towards B. Slight shift of electrons towards B. Okay, as a result, what you will get? A become partially positive and B becomes partially negative. And we are using delta positive and delta negative. Delta positive means partial positive charge. Delta negative means partial negative charge. Okay, that means now a charge is developed. A becomes partially positive and B becomes partially negative. The bond is not yet cleaved. Bond is not yet cleaved, but A becomes partially positive and B becomes partially negative. And this is what is called polarity of bonds. Polar. A bond is said to be polar when a charge is developed. Okay, is it? When a charge is developed, it is said to be polar. So what is the reason for polarity? Polarity of a bond is due to change in electronegativity. So if two atoms which are connected by a change, is it? If two atoms with this different electronegativity are attached, definitely there will be polarity. Okay, polarity means when two atoms with different electronegativities are there is a shift of electrons towards more electronegative atom. As a result, more electronegative atom becomes partially negative and less electronegative atom becomes partially positive, delta positive and delta negative. And this type of charge development is called polarity. Okay, So a polar bond or polarity is indicated by the symbol delta plus and delta minus. Okay, and we can have another example. Before discussing example, you should know what is a order of electronegativity. Already we have discussed this under first sum. You know, that fluorine is more electronegative than oxygen, than nitrogen. Then you can have chlorine in sulfur in between this, then bromine. So this is simply we are presenting some atoms only. Carbon, which is almost similar as that of hydrogen. Therefore, if you are having a bond like this, it is not said to be polar, because electronegativities of carbon and hydrogen are almost same. Okay, but then if C is attached to oxygen, let's have a look. Oxygen is more electronegative than carbon. Therefore, what? There is a shift of electrons towards oxygen. Is it? A shift like this. A shift like this. As a result of this shift, what you will get? Yeah, as a result of this, C becomes partially positive and O becomes partially negative. So, delta positive and delta negative. Now, this is a polar bond. Okay. So, now this is said to be a polar bond. And this way, we can have polarity. So, polarity of bond means in a covalent bond, if two atoms are connected by a change in electronegativity, there is a shift of electrons towards more electronegative atom, and that can be represented by delta positive and delta negative, and that is said to be polarity of bond or polar bond. So, the polarity is explained based on the difference in electronegativity. Okay, so that is what is called polarity, and we will discuss this in next module also. And in your textbook, polarity of bonds is given in module 2. I think it is in page number 33. So you just focus on polarity of bonds. In syllabus, it is given in first sum itself. That is why we have discussed this here. Okay. The next we can think about types of reagents. Already we have discussed types of reagents in your online class, but for absentees and due to the importance of this topic, I am repeating in short. Nucleophiles and electrophiles, types of reagents, that means reagents that we are used in organic chemistry. Okay, in the coming sessions we will discuss reaction mechanism. In that case, you will be familiar with nucleophiles as well as electrophiles. So just have a look or just refresh what you have studied in regarding nucleophiles and electrophiles. Nucleophiles simply meaning they are nucleus loving. This is a very simple definition you can remember. They are nucleus loving species. Nucleus loving species means they are positively charged nucleus. So when a reagent is attacking nucleus, that means that reagent is negatively charged because nucleus are positively charged. Is it? So nucleophiles can be further defined as, what is a simple definition? They are nucleus loving species, or you can say that nucleophiles are atom or group of atoms with unshared electron pair. With unshared pair of electrons. With unshared pair of electrons. That means excess electrons, or they are negatively charged. Please remember, nucleophiles, nucleus loving species. ഇത്രയെങ്കിലും മെയിനായിട്ട് ഓർത്തിരിക്കുക. Nucleus loving species. That means atom or group with unshared pair of electrons, or they are having negative charge, negatively charged species. So it may be charged or neutral. Okay, nucleophile may be charged or neutral. For charged nucleophiles means negative charge. You can have some examples like OH minus, Cl minus, Cn minus, like that. Charged. If they are neutral, it should carry a lone pair. So lone pair atoms, atoms with a lone pair. That means nitrogen, oxygen, is it? So you can have NH3, H2O, ROH. So these are some examples for neutral nucleophiles. So these are neutral and these are charged. So all should remember at least 2 example for neutral nucleophiles as well as charged nucleophiles. Okay, and again another point is that nucleophilicity, that means strength or power of a nucleophile, that is called nucleophilicity. Nucleophilicity can be improved, can be enhanced by the presence of electron donating or electron releasing group, when because these are electron excess species, negatively charged or with the excess electron. So if you are having some electron donating groups, definitely the strength of nucleophile will increase. Negative charge species aana. So if you are attaching another electron donating species, definitely nucleophilicity will be improved. So these are some points, or at least 4 points plus 2 examples you have to remember. Then electrophile. Electrophile definition will be simply what? Electron loving species. Electron loving species, and electron loving means definitely they are either positively charged or electron deficient. Either they are electrophile. Electrophile means either they are positively charged or with they are electron deficient. Electron deficient species, or they may be positively charged. Okay, electron deficient or positively charged. And for that you can have positively charged electrophiles like H plus, H3O plus, or NO2 plus. Is it? Some is a lot of Cl plus can also be given. Okay, these are some examples for positively charged electrophiles. For electron deficient or neutral, for neutral electrophiles, you can have examples like neutral electrophiles are Lewis acids. So you know what are Lewis acids. So you have some examples of Lewis acids. And for neutral electrophiles, you can have Lewis acids like AlCl3, BF3, BF3 നമ്മൾ പഠിച്ചിട്ടുണ്ട്, ZnCl2, etc. Okay, then sulfur trioxide also can be written. These are some neutral electrophiles. So electrophiles as well as nucleophiles, Nu minus and E plus. So these are the two types of reagents that we are commonly used in organic chemistry. So there will be a question of 4 marks. Okay, write a note on nucleophiles and electrophiles, or 6 marks. What are the common reagents used in organic chemistry? Okay, so in this video we have discussed bond fission, homolytic and heterolytic. It's important. What are the products of homolytic fission? Free radical. Heterolytic fission, cations and anions. Then arrows, curved arrow and fish hook arrow, half hook arrows. Arrows you should remember. Okay, not for exam point of view, but for information you should know what is the meaning of curved arrow and half hook arrow. Then polarity. Polarity is due to what? Polarity is due to change in electronegativity. Okay, so you should remember the order of change in electronegativity. Is it? Then finally types of reagents, nucleophiles and electrophiles. Okay, thank you.